Hey folks, welcome to this 39th edition of the Hasura Community Call. This is launch day. This is our first community call of the year 2024, and we're very excited to be here. And we're excited to have all of you folks here from all over the world joining us. Here's our agenda for today. We're going to be taking a look at just a few things. To begin with, we are going to talk about a big announcement, which is V3 engine open sourcing. And Tristan, who's up there with me, will be talking a lot about that. Additionally, we're going to talk about query plane exporter and tracing. So we'll look at some ways of being able to diagnose bottlenecks that happen for any type of query execution that you have. It's something that I've been looking forward to for a long time. I know a lot of you have as well, is joins with TypeScript functions. So we'll see some really cool improvements between V2 to V3 that allow for some really great, powerful queries to happen across not only data sources, but also across different microservices that you've brought into your graph. Finally, the last two things that we'll close out with are going to be talking about our development flow state. So we'll have Akshay and Bilal talking about the development nirvana that is working through the local development process and using things like our VS Code extension and our new CLI. And then finally, we will have Rahul, who is a familiar guest of the show, come on and talk about a backlog bash. So look at some community issues that have been brought up on GitHub, and we'll talk about the bash that is underway to make some strides in all of that. Let me go ahead and jump into our first slide here. So I'm going to bring on Tristan and Vamshi. Vamshi, if you want to go ahead and jump onto the stage, that'd be great to have you here as well. Tristan, how are you doing?
Hey Rob, how are you doing? I'm doing awesome, man. I'm so excited about this one. I think this is something that a lot of people have been waiting for a long time, and really excited to start talking a little bit about how we are officially, guys, officially V3 is open source, which means that you can run Engine. And to kind of kick things off, I'm going to do a quick little screen share here, if that's cool.
Yeah,
And I
absolutely.
just want to show this little demo here. I'm going to show you guys what I think you care about, which is something that I think is important, which is the network tab, right? So let's take a peek at this network tab here. And what I've got here is I decided to pick two really crazy databases. We're going to go with Quadrant, which is a vector database, and we're going to go with Terso, which is SQLite. And I want you to just watch this network tab fly. So let me go ahead and send some requests here, and you can see we're dipping down. I can almost get down into single digit millisecond responses. This is with the cross database join, guys. So, we're almost running at native speed. Like I'm pulling 12 milliseconds there. It is lightning fast. And I have this available as a really cool demo. Actually, we'll drop it in the chat that you guys can run yourself locally with multiple different connectors. It is the SuperGraph NDC demo. So you guys can go ahead and pull that up. I'll have somebody drop that in the chat. And of course, as always, V3 is available, and you guys can go and play with it now on our master branch inside of the GraphQL engine under the V3 folder. So check that out. But really exciting stuff today. Super excited to just finally be able to say that V3 is open source. So please play with it. Let us know how it works. Let us know what you think, and give it a try. That's all from me for today, Rob. Not too much other than that, but I think that's pretty exciting stuff.
Yeah, power packed. We appreciate that. I'm going to have Vamshi go ahead and join us on stage.
Hey folks, some of the improvements that we've planned for permissions in V3. First one is better explained with an example. Say you have a Slack-like model where you have user channel messages and a user channel membership that is described by a user channel table. Your permissions are going to look something like this. So for user channel, you're going to specify if the current user can access the channels. And then for channel, if the channel's user is the current user. And for message table, you're going to say if the message that belongs to the channel has access to that particular user. Now, the problem with this approach, though, is that if you have to change the permissions of user channel, then you would have to go and edit the permissions of like all of these tables. And as you have more and more nesting, this becomes like really challenging. So the pattern here is essentially like permissions are derived based on the permissions of the related tables. So what you want to actually say is that message is accessible if the message's channel is accessible. But channel is accessible if like channels users are accessible. Something along these lines. So what we are planning to introduce is a feature that looks something like this, where you're specifying user channel permissions. But when it comes to channel and message, you just refer to their parent permissions. So what this means is that if you were to change user channel permission, you don't have to change channel and message permission. This is essentially a shorthand syntax to what you see here. So that's one thing. And this is the next item as allowing multiple roles per request. So this has been an ask since like GraphQL engine was open sourced. Essentially, like allowing multiple roles per request is a way to compose permissions. And what we've done in V2 is that we introduced a concept of inherited roles or role inheritance to compose permissions, except that it doesn't really solve all of the use cases. One particular use case is where you have your metadata and your auth system completely decoupled. So you want to define permissions for roles in your metadata, and you want to assign these roles dynamically to the users. You do not know ahead of time the combination of roles that you're going to use. So this is what's like not possible with inherited roles. So ideally, you want to specify X as a role to be reader and editor, and GraphQL engine would magically compose these permissions together and like process the request based on the permissions assigned to both these roles. Now, the challenging aspect of this is the two challenges on why we have not implemented this in V2. One is the V2's architecture itself like prevents or makes it very hard to implement something like that, something like supporting multiple roles per request. But V3's architecture enables this thing. However, the other challenge with this is how do you define the semantics of merging permissions? So if there are no overlapping permissions between these two roles, it's very straightforward. Say reader has access only to read a bunch of tables and editor only has access to mutate a bunch of tables, then the combination of these roles is very straightforward to understand. However, if these roles have permissions defined on a table, if both the roles have permissions defined on a table, how do you compose them? Right? Like for selects, at least with inherited roles, we more or less solve the problem. But again, it's like quite complicated. If you have like same set of columns, then very straightforward semantics, it just becomes like an OR of filter of permission 1 and filter of permission 2. That is, you get access to both sets of rows. But if you have like a different column sets, then it's complicated, right? Like, so if you have a user table where the public role can access ID and username of all the rows, but a private role can only access the user's role, but in addition, they can access email. So if a request were to come in with public and private, what should the semantics of this query be? Ideally, you would want email to be null for all rows except for the current user, right? Except this behavior is kind of like hard to get from a database. And in fact, no database supports this out of the box with row-level permissions. What V2 has done is it borrowed some ideas from an old Microsoft paper about cell-based authorization, and it implements that. And in fact, like no other database does this. For mutations, though, this is fairly challenging. If there are different presets, we have no way of establishing which preset is a better preset, or like which preset is less restrictive. And hence, what we've done with inherited roles is that whenever we encounter any of these cases, when we're deriving the GraphQL schema for the inherited role, we would reject the metadata if we run into these cases. And however, this again like is not particularly useful because you want to like combine these two permissions even for mutation. Say you have like a user and an admin role, and admin has always a higher priority than user. You would want to like allow this request to go through, even though their presets are different. You would want to select the admin's preset over a user's preset. So there are a bunch of conflict or merge strategies that we could come up with. The most straightforward thing is we could fail the request if there are ever overlapping permission, and we could have some sort of like conflict rules defined in the metadata. You could say admin insert takes precedence over users insert, and you could have it like more granular, like you could have it per table, or like you could have like a simpler strategy, which is that when there are overlapping permission, pick the permission of the first role that's present, that's presented. Now, yeah, this is one approach to this problem. The other approach, which we're considering, is a more general approach, which is you implement a full-fledged policy engine into a GraphQL engine. And the idea is that you move away from Hasra's notion of like what permission should be. At the end of the day, what GraphQL engine requires is that when a request comes in, you need the permissions associated with all of the tables that are being accessed in that request. So if we could like somehow provide a way to like let user define what permissions come in per request, then you don't have to subscribe to Hasra's model of permissions, like whether it's RBAC or whether it's RBAC with a bunch of improvements on top of, like it doesn't really matter. So I think it's better explained with an example. So if like the current scenario is that when a request comes in, Hasra would read, provided like this previously discussed feature is implemented, you would read X Hasra roles from the request body, and then you would traverse the GraphQL query, derive permissions from the list of roles using various conflict strategies, and then finally execute the operation with the permissions obtained from previous step. With the policy engine, what would happen is that we just read user session, the tables and columns that are referenced in the query, and then we would pass on this information to the policy engine. Hey, like this is the user session. This is what is being accessed in this query. Now, this policy engine is expected to evaluate the policies that the users have written and return a bunch of permissions. And now Hasra would just apply these permissions and execute the query. And there are like several variants of like policy languages out there, like mostly derived from like Datalog or Prolog. If people are familiar with like Regos that are like, you know what I'm talking about. But let me go over an example. Right. So the idea with the policy engine is that it's much more general than like what you could currently do with Hasra's permission system. For example, you could emulate Hasra's permission system just using this set of policies. Here you have like Hasra style permissions defined for public role, and on product table, you have a bunch of permissions. And for an analyst role on product, you have slightly more general permissions than what is allowed on the product table for public role. So like this thing implements a merge strategy, which is a conflict strategy, which picks the first role from the, just move these things. So if you have X Hasra, analyst, when we evaluate this, you could see that. So what we want is we want this policy to return a bunch of resolved permissions with this input. So the input is that a particular GraphQL query has come in, and these are the tables that are being accessed on this in this query. And the user information is as follows. So once you have something like this, you are expected to output a bunch of permissions. So here you could see, because the public role has come in first, the product permissions have resolved to like a weaker set of permissions. Now, if we were to change this, you would see that like it has derived like more general permissions that are defined for analyst role. So again, the idea here is that you could define whatever permission model like that, whatever system better suits your application, right? If, for example, you have like attribute-based access control system, then like, for example, this policy just says that if the user has an admin attribute set to true, then you would get like all permissions for all tables. So that's pretty much these 5 lines of a Rego policy is doing this. Again,
Just a heads up, we've got about a minute left in this segment.
All right. Yeah, I think that's it, folks. We are just experimenting with a bunch of these things. We would like to hear your input on what this would open up, what kind of use cases that would get solved by these approaches. Yeah.
Awesome. That's great. We know that permissions is a really robust and important feature for our users. We're very proud of it, and we're happy to see this iterative work happening as we move into V3. So thank you so much. Let me go ahead and share screen, folks. All right. Next up, we are going to be talking Query Plan Explorer and tracing. So we're going to bring on Paritosh and Julian. All right, I'll turn it over to you folks.
Hey everyone, me and Julian, we are going to talk about the Query Plan Explorer and tracing for Hasura DDM. So Julian, yeah, go ahead and tell us about the agenda.
Thanks, Paritosh. Yeah, so this is a bit about what we're going to talk about here. The important thing for you to know is that we're going to talk about 2 tools that are going to help you create performant and APIs at Hasura, and also a good way to debug them, to make sure we know everything we have to about them, and make sure we know where to find the little pieces that can be tweaked, so we have the best API we can possibly build at Hasura. So we'll start with the query plan. We'll see what features it has, what it allows you to do. We'll then do a comparison with V2, and then go through some examples that show the different use cases where you can take advantage of the Query Plan Explorer. And then we're gonna talk a bit about tracing, which is another really exciting way to get to know the different requests that are coming to your API and see what's happening underneath. So we also go through some examples there. So maybe we can start by looking at the Query Plan Explorer. As you can see here, it's gonna, every time your users fire a request against the API you built at Hasura, you want to plan how that's gonna behave. You want to know, because Hasura, as you know, Hasura DDN is a microservices architecture. You want to know which microservices it hits, and where are you gonna have like parallel execution of tasks, where are you gonna have sequential, or what's local. And this is also that you know how to optimize Hasura, but also how to understand. You understand how everything works while you're building your APIs. So, and this is very different to the explain functionality in V2, because we also gave you a way to understand your queries a bit more. But in V2, we only showed the execution plan and the SQL query explain functionality. So you know at the query level, at the SQL level, how everything behaves. But now in V3, we also handle remote relationships. So that means you'll have a wider understanding of where of how your requests will work. So maybe we can just show you some examples that this whole thing is clear, and Paritosh will make sure you get to know a bit more about this.
Yeah, awesome. Thanks. So we will start with a simple example. So this is a query where we have a model called users, and we have another model called cart, And those two models are actually they are from the same data source. So basically, they are backed by the same data connector. And we have a relationship between user and card, and that relationship is named as cards. So this is a simple example where we are querying a model and a local relationship. So let's try to see how the query plan will look like. So you can see that it only has a model select because the local relationship is actually handled by the data connector. So what Hasura V3 engine will do, it will just create a query and it will send it to the data connector. And you can click on this model select and see what that query is and what is the actual execution plan and the SQL query. Like if it is backed by Hasura Hub Data Connector, then you can see the execution plan and the SQL query, and you can also analyze the SQL explain. Moving on, here we have a remote relationship. So we have a model called users in data connector, which is backed by a data connector. And we have another model called review, and we have, which is from another, like some other data connector. And we have created a remote relationship between the two. Now, as you can see here that this will be a sequential execution. So first we need to fetch the user model, because for fetching the reviews, you actually need some data from the user model, right? So first we fetch the user model, then for each of the user we do the model select from the reviews model, and then we do a hash join. So hash join is basically making sure that uh, the review for a particular user goes with the particular user data. And moving on, you can see that we can have some more complicated queries. So here we have two root level queries. One is the users, one is fetching data from user model, and another is fetching data from product model. And then we have remote relationship reviews and orders for users. Now let's see what the query plan looks like. So here we can see that it is going to execute things parallelly. Here we will have a parallel fetch from the products model. And then we have some sequential steps where we are fetching data from the user model. Then we are going to parallelly fetch from reviews and orders model. And then we are going to hash join, and then we will get the result. Next, we have a nested relationship. This is also interesting because here we have a remote relationship with a model which actually has a local relationship with the top level model. So we have a model called user and a card, which both are backed by the same data connector. And then we have a cards item, which is backed by some other data connector. And we have a relationship between card and card items. And then we have reviews, which have a relationship with the user's model. Now, the query plan for this looks something like this. First, we need to select data from users, because once we have the data from user, then only we can fetch the reviews or cart items. Now, this model select will be also interesting because it will include the data for this local relationship as well. Next, we will do a parallel execution where we fetch for the reviews. So this one, and also for the cart items, and then we will hash join. Yeah. Moving on to tracing. This is another very important feature which can be used for debugging and optimizing. Yeah. So Julian, go ahead.
Yeah. Thanks, Paritash. Yeah. So traces are really important because we saw the explain functionality. That's a way to plan your queries. That's a way to plan your API. But the good thing about tracing is that you can see every request that hits your API and see its behavior, see where the parallel execution happened, where the sequential part happened, where the different microservices that Hasura operated. And that's great for debugging. That's great when you have some slow part and you want to know where to optimize that. And also to monitor performance in general. So everything's better with an example. So now Paritosh will show you a bit more about tracing.
Yeah. Thanks, Julian. So we will start with a simple example where we have a selection from a model called users, and we have a remote relationship with another model called reviews with the user, and then we have two more selection from other models called products and cards. And all the user, product, and cards are belonging to different data connectors. So the tracing will look something like this. It is a bit small. I'm sorry for that. So we can see that first it hits the outer layer of the endpoint slash GraphQL. Then we handle the authentication part, and once the authentication part finishes, we actually start handling the request. And for handling the request, we have more steps like execute and execute field plan. And in the execute field plan, we can see that there are three NDC requests starting at once, right? So these are parallel execution of the three root level fields that we saw: users, product, and cards. Now, for the first execution, when it finishes, we can see that another execute NDC query starts. So this is for the remote relationship for the reviews. And similarly, this tracing also helps us visualize how much time is spent for each of the NDC queries, so that we can see that we can optimize maybe somewhere that this NDC is actually taking much more time. So maybe we can think of some ways to optimize this. I will show you a quick demo because this was too small to show. So I have set up. So by the way, all of these features are live on prod, so you can go and actually check it out yourself. So this is the explain query button, and clicking on this will actually open up the explain. And you can click on all the model select and actually see what is the query request. And this will also include the NDC explain soon. And you can also click on these for each nodes and see what are the requests that are being done. And when you click on this view trace, so when you execute the query, you will see this view trace button here. And clicking on this will actually give you some trace ID, and also it will give you the query details. Here also you can see the explain explorer, right? And then we have some topology where you can see what are the APIs, where are the connectors, where are the data sources. So I think these are too small to look, but yeah. And then finally we have this tracing where you can see every bit. So here you can see that the handle authentication took 41.08 milliseconds and so on. And then we have this execute, and clicking on each of these traces will give you more information about it. So for example, here the database request was super fast, and you can see like there are much more information if you want to debug it. And if there are errors, then you can also see the error messages here. So that's all from the tracing part. And finally, we have the documentation for these two, and you can check out the documentation. And yeah, and so these are on prod, so make sure to check it out and play around with the tools.
This is awesome and really helpful stuff. I know for me, I was using another service, building something over the past couple of days, which I won't name, and debugging was a pain. If only I had these tools right in front of me like this, it would have made things so much easier. So thanks, folks.
Amazing. Thank you.
All right, thanks. I'm going to go ahead and bring Suraj up on the stage. Something that I've been looking forward to for a long time, and a lot of people in the community have as well, and that's doing joins with TypeScript functions. I'm going to let Suraj do a little bit of an intro and talk about what he's going to be demoing, and then I think I actually have a recording that we'll play through. So Suraj, we'll let you go ahead and come out here.
Yeah, sure. Yeah, I'm super excited to talk about this because this has been something that we've been, working out and trying to iterate and, make it a better experience. I'll be talking more about the bringing in the Lambda function sort of experience to, Hasura and getting it onto your graph rather than thinking just about bringing custom logic onto your GraphQL API. It's all about how you extend things on your data domain or graph. I'll also be talking about extensible remote relationships and how you can stitch together. Today I'm really excited to give this demo on the Lambda functions with the join or relationship feature. Together it can play great magic, which I would say, because It's not just getting everything onto your GraphQL API. It's about a way to think about how you bring things onto your graph or onto your data domain. Not only having the perspective of getting everything onto a single data graph, but also performance and security and other things in mind. All right. So to start with, I'll give a quick update on the new runtime. We have a new Lambda functions runtime, so which means you can write TypeScript functions on Hasura with the latest Node.js TS connector, which is again open source. So you can take a look at github.com/hasura/ndc Node.js Lambda to see what are the new things which we are building on. And then essentially you can build or write TypeScript functions and get that to your Hasura DDN. All right. So like I mentioned, your TypeScript functions can have any npm libraries. You can write async functions. You can do that. With that, you can do things like data enrichments, transforms, and so on. End of the day, you can deploy your connector on Hasura Cloud to make everything deployed on a certain place. Okay, the next update is quickly on the relationship front, which means now you can add relationships to commands as well. So which basically opens up a new way to think about commands. You can do command to command relationships, which are similar to the V2 action to action use case, which was being asked from the community for quite some time. And then you can also join things from your model, which means you can join data from your your database or data source, and then you can join that with your command or a TypeScript function. So we'll be talking more about the TypeScript function use cases. So so on the TypeScript function side, we'll also see how we are addressing the n+1 issue, and then how we are thinking about parallelism, how we are thinking about presets. All right. So to start with, let's see. Let's take an example of this query. Essentially, what we are building is something like this. And if you look at the first part of the query, it is basically querying a particular user with the user ID. It can again be simplified with a permission, but for the demo, I'll be putting a simple relationship use case to show the power. And on the second line, as you can see here, we'll be fetching the orders from a particular microservice. Imagine that this is a underlying brownfield microservice which you want to bring into Hasura. We can simply do that with the new TypeScript connector. And then similarly, you have a different microservice that can resolve a particular product, which can also be done with the TypeScript connector thing. And let's say your product microservice is giving you ID, product image, description, and so on. Maybe this brownfield microservice is something that is not touched for a long time, or maybe it is a third-party microservice, or your team is not having access to this particular microservice to add things on top of that. But your client, or maybe whoever is consuming this GraphQL API, has the power to get more a better image, rather than using the older product image or maybe a single product image from the system. So what you can do is you can extend the product type with the relationship with a new microservice C, let's say, and this microservice C can be anything which you are writing, or maybe the microservice C itself is a Lambda function. And then what you can do is you can write that particular logic on Hasura TypeScript function and pass on this product image to do the data enrichment, and then give you a high resolution image if your CMS system has capability to resolve that, or maybe something of that sort. So the point is, you can not only extend or maybe like bring in your microservice to Hasura, you can also do data enrichments on a particular type and then resolve it on the client end or maybe the consumer end. Awesome. But one question that probably you will think about, when you see such examples or such queries, GraphQL queries, is, hey, how does it really perform, right? That could be too costly, right, from what we're thinking from the query end. It's actually not. If you're thinking about making sequential queries like this, it's not actually the case. Hasura make an optimistic or optimized query to support get the best out of the TypeScript functions. So in this example, you can see it makes a single request to database, and then it makes a single request to microservice A, and then microservice B, and microservice C. So NDC, the TypeScript runtime will make sure that the query to a particular NDC query, NDC connector is combined. So which means it queries all the orders in one go, and then it queries all the products right after that, and then after that it queries all the HD images or the data enrichment function. That's how it works. Let's see this in action. So I have a simple GraphQL Hasura project. I'll just minimize this. Yeah. And then I'll start with a basic example. Maybe I will go to the previous or first commit. Okay. So I have a microservice. Let's say this is your microservice, and then basically what it does is generate some fake data, and then it resolves orders and orders for a particular user, and then it also resolves product for a particular with the product ID. It's a simple Express.js application. Let's imagine this is your underlying brownfield microservice. It could be anything, like it could be Wiki legacy, or it could be anything, right? So let's say if I want to bring in my Postgres data source, let's think of this example again. And if you remember, I'm bringing in users from the Postgres table, right? And for that particular use case, I have a Hasura Postgres data connector which resolves data from from my Postgres database, and then it has types associated with that as well. Basically the user type, and then with this particular setup, what I can do is I will have I'll have my orders readily available on my GraphQL API. Let's try to pull this up. I am pulling a particular user with user ID 1, and then Hasura makes a request to the Postgres database through the Postgres data connector, and then it resolves all the data. Now what we can do is we can quickly get on to a different commit wherein I have add orders, maybe add products with order. So I'll show the remaining things quickly on the Hasura extension side as well. So how did I create all these things? Maybe you'll be thinking, hey, am I writing all these things by hand, or is VS Code helping me to do that? So all that I have to do is I have created my data connectors, and then I can do I can simply import things using this new sidebar, wherein I can simply import things as well. I've already done that, and I have created users, which you already saw, and I've also imported two commands. One is get orders for a user and get product. And if I want to see where this is being declared or defined, I can simply click on it. It takes me to the command definition. So I have this get orders command, and I have also created a remote relationship, or maybe like a command to command relationship. Essentially it is a type to command relationship, but because anything that resolves is a type, right? So a command, so I'm defining, or I'm specifying my source as order and my target as get product, right? So from the product, I'll have a product ID, and that product ID is being passed on to the get product microservice or the command as the argument product ID again, right? And let's see this in action. I'll go to the next, build, wherein I've already created. I have my orders ready here, and I'm fetching orders ID, user ID, value, and product ID and ID for just to make sure that I'm getting everything correctly on the orders front. And now let's pull in the product details as well. So I can now query products like see, look at this. Like what I'm doing is I'm querying my orders, and I'm also querying the product details associated with that in a single API. And if you look at the trace, it is making a for each request. It's not really making sequential request, or it's not really going and making that many get product, that kind of calls. Instead it's making like one get orders and one get product call. Let's say if your microservice is capable enough to handle one level in, that can also be configured later. I'll come to that in a bit. Now let's see what if I want to do some data enrichment sort of use case. What I'll do is I have created one more microservice here onto my functions. So as you can see, the first command which I created is get orders for user, and then I also have a command called get get product, and I will get into the latest commit to show you. I have a data enrichment function, which is at the moment it is a simple logic. Basically adds minus ht.jpg to the existing image URL. But the beauty is, how does it actually connect to the GraphQL schema or to your data domain seamlessly? This can be anything. Maybe it is calling your CMS and then making sure that the function, the files are provided in a better way, or anything, right? So you have your function ready, and then what I'm doing is I'll go to my function, functions.html, and then I'll see the new command here. So let's say if you don't have this command on your schema, all that you have to do is refresh data connector and then call functions. What that does is it automatically introspect your functions, GraphQL function which you have, the TypeScript functions which you have created, and then it generates the schema for that. And let's say if you don't have this function or command tracked, what you can do is Hasura will automatically suggest you, hey, why don't you track this? So I can quickly go ahead and do this from here. Otherwise I can also do that directly from this, and then I can specify where this needs to be added. That's it. I don't really have to write any of these, but you also get the freedom to decide what you really want to do. So let's say in this particular example, I want to go to this particular function called get product, and then I am going to this get product. Let's say I'm creating a new relationship called HD image. Look at this. I'm not calling it get HD URL or something. I'm specifying it as HD image, and then I'm specifying how it needs to be connected. And then with that, I will be able to query it as a simple, like it looks like a single type, right? Like you're basically extending the type, but again you're getting a string out of it, so it blends into the type products. So let's say if your client doesn't really bother about the product image, you don't have to query the product image. You can simply query HD image. Let's say if your HD image is not needed, you can query like this, and then you can also see the traces to see only two sort of NDC request. It's loading, but then you can see this here as well. Yeah, here we have the database request and then two TypeScript NDC requests. All right, so we're out of time, but let me show you like what are the new things coming up. So you'll get new way to control the parallelism. Let's say if you have, it's already live. You can decide when you're writing the function itself, you can decide how the parallel execution should happen. You can read more about that, and we are also bringing in the concept called presets, so that you can bring in your context to a particular command. You can resolve headers, role, or user ID, or any other session variables on your choice. We're also thinking about empowering developers to do parallel execution. Rather than, let's say if you have a Lambda function, and then you have a requirement of executing it on a bulk scenario. In such scenarios, maybe you will be able to handle this with a custom logic. So how do we support that is also something that we are thinking about. So with all this up, your feedback is the most valuable thing. So feel free to write to us, or maybe like start a discussion on Discord or GitHub or anywhere where you find us. You're happy to help, and happy to collaborate. All right, thank you folks.
Awesome. Thank you so much, Suraj, for that demonstration, for the video as well. That was awesome. Folks, do check out the information that we have for the resources in this call. If you're curious, and I know that lots of people like me are excited about using this feature inside of their APIs. So there we go. Let me go ahead and jump over to our next set of presenters. And as is tradition, we are going to end up going just a little bit over on time. It should be no surprise there for the folks that are on the call that have been here before. But let me go ahead and have Akshay join us on stage, and I'll share my screen as well.
All right. Hi, I'm good. Thanks. Busy, exciting time as we gear up for beta.
Yeah, absolutely.
Yeah.
So you're going to be talking to us a little bit about some development nirvana. Is that right?
Yep. It's all about that flow state, whatever helps us get there. So I think with DDN, like it scales to the planet and like large projects and large teams. And as part of that, we want the tooling to scale to like every developer's workflow. So excited to hear what you guys think about the workflows, and excited to learn more about what your particular workflows look like, so we can accommodate that. Hi, I'm Akshay from Hasura, and here's how we're making the developer experience even better for Hasura v3 DDN. What is flow state? The developer can focus on bits that add value. There are workflows that don't get in the way, and the developer always has full control and clarity over what's happening. To set some context, here are some changes we're making to connectors and the resource model. The Hasura supergraph can talk to any data source, including niche or custom sources. To scale this out, the data source specific bits are spun off into connectors. For example, you could start a Postgres connector, which is configured to talk to the Postgres database. Then the engine talks to this connector to bring the database to the supergraph. You could also have a TypeScript functions connector. Here, the input to build the connector are TypeScript functions and some package dependencies. One of our priorities is to foster an ecosystem of connectors, and we're unifying all connectors to use this same model. So here, you write your TypeScript functions and then build the TypeScript connector. You'd then configure your Postgres connector and build it. Then you'd configure your supergraph to talk to these connectors using the connector link metadata object, do some domain modeling with models, commands, object types, perhaps add some model permissions or type permissions and relations, and then build your supergraph API. So clearly there are quite a few moving parts. With the beta release, we're introducing workflows that support these end-to-end with resource-based tooling that unifies operations across all the different kinds of things in the DDN system. If you know about supergraph metadata like models and commands, or infrastructure resources like environments or subgraphs, you can immediately begin to operate on them. Hasura v3 DDN is built to scale to large projects and multiple teams. A significant way to make this possible is through our code-first approach and developer tooling. So there's day one workflows, onboarding a new data source, or creating a supergraph in a fast and fun way. But we're also committed to making the day two workflows smooth. This is when you need iterative workflows, or when you need support for the software development lifecycle across multiple environments or feature branches. Here's some examples of workflows that we're looking to enable through the Hasura tooling. Let's say you have a supergraph set up with some TypeScript functions. But what if you could simply change your TypeScript functions and get an updated GraphQL API? Now that's iteration. Here, the CLI tooling would notice the change to the TypeScript files and then build a new connector. Then it would update the supergraph metadata, including the commands and object types. Here, for instance, we notice that the decrement function has been added, the increment function has been removed, and the sum function has its arguments and return arguments changed. And then the tooling would automatically go ahead and build a new supergraph build with its own API. And all this happens automatically or with minimal user intervention. Here's another example. We've already seen that it's super easy to add a new Postgres database. But what happens when you change the schema? One of the strengths of Hasura is that it is a data-first approach as opposed to an API-first approach. Even though with V3, the API is super configurable. So we're working to help developers focus on the valuable portions of modeling their domain by automating everything else. The Hasura CLI can pick up changes to the database schema and interactively offer to add, merge, or remove existing supergraph configuration to create a new supergraph API. Of course, the tooling can only get some bits of this right. It can't, for example, set up your permissions for you, but we've gone a long way in helping the developer focus only on the value-adding bits. So that's what we're working towards. Do let us know what workflows you'd like to see supported. What are the tedious bits building with Hasura v3 today? And how can the tooling help you focus on what's most important? Getting stuff done. We're also making improvements to our in-editor experience, including ways to author and visualize your metadata. Next up, Bilal to share more details.
Hi folks, I'm Bilal. I'm with the LSP team at Hasura, and this is a demo of the new tree view and autocomplete that we've built for the VS Code extension. So right now, what I have done is I've added a Postgres database that I have named PGDB to my metadata, but I haven't really imported anything from that database into my metadata. And we can see that in the tree view. So what it's doing is it is listing everything, all the data sources that I've got. And it's telling me that from PGDB, there is really nothing as a metadata object that's being used, while there are a bunch of unimported metadata objects in here. So let's go ahead and track something. The first thing I'm going to do is track something using a command, and we're going to do track collection, and we are going to track cards. Default, and what default does, by the way, is it creates separate files for every single model that you're going to track. So it's very easy for you to reason about the metadata and the models that you have. We're going to refresh this. We're going to refresh this. At this point, if we create a GraphQL API, cards is the only thing that we'll be able to query from PageDB. Let's go ahead and track cart items as well. And I can do it from the tree view itself by clicking on this plus item. I'm going to click on this plus. It's going to ask me the same thing again. I'll select default, and we have a new file for cart items. And we can see that cart items has now been added as a metadata object. Now let's look at the new autocomplete that we've got. So we're going to build out a relationship for carts and cart items. So I'm going to start typing kind relationship, and the autocomplete is basically suggesting everything that it thinks matches with what you just typed. And for relationship, that is the top match. It's actually telling us what is the object of the relationship, or what does a relationship object look like. And we will select that. We're going to name this cart underscore items. For source, the source is carts model. For target, we can do a control space, and we can see that target is supposed to be a complex property. And there are two possibilities that we can have for target. Since this is a model to model relationship, we'll select model. The name of our target model is cart underscore items, and that is also suggested to us. Relationship type is an array, and that again is suggested to us. For mapping, what we're going to do is we're going to again do a control space, and we're going to go ahead with field path. And the column that I want to link is ID. And for target, again, we're going to go ahead and select the model field. And again, we can do a control space here and it'll show you all the possibilities that we can select, but we're going to go ahead with cart ID. Now that we have that, the last thing that I want to show you is the track all command. So for a data connector, if I click this plus sign, what it's going to do is everything that can be tracked inside this data connector or this data source will be tracked as a metadata object. So let's click this. Let's select default again. And we've tracked everything that we could possibly track from this PGDB data connector. And we see that there are a bunch of models that are available to us right now. That was all. Thank you.
Excellent. There we go. So lots of updates to the in-editor editing experience for metadata, getting things just right for V3. We're going to go ahead and jump over to the last segment that we have before our closing comments. So Rahul, I'm going to go ahead and call you up on the stage if you wouldn't mind joining us.
Hey Rob, and how's everyone doing? Thanks for staying beyond the hour, just like always.
Just like always. Would you like me to click through or would you like to share screen?
Sure, you can click through and then we can talk to the next slide. So we're
Sounds great.
introducing a new section to the community call called Backlog Bash. And the main objective is to foster development, collaborative development with all of you and be as transparent as possible. So we'll be providing you updates on new RFCs like Vamshi presented and new developments as Bilal and Suraj presented today. And also invite you to engage and collaborate with us on these and let us know through GitHub or any other medium what you want to see on the V3 platform. So I'm going to talk about two things today. On the left, there's a top GitHub issue out there, which is single object lookup by unique key. And it's been asked about for multiple years. And finally in V3, with the new metadata structure, providing strict types and just making the metadata not a black box, we are able to provide this feature in V3. So have a look at that issue. And the second one is an RFC, which we are working on, which is adding descriptions to GraphQL schema. So if you let me share my screen real quickly, Rob, I'll go through details here in a few minutes.
Absolutely.
So this is a use case where what's been asked is that, can we query by having a unique ID, which is a combination of these two fields? And what you would typically do is use a where clause, and where clause is not very efficient because you are not filtering data, but you're just requiring that one value which corresponds to this unique combination. So in V3, we have supergraph modeling, which has these different types. And within the model type, you can see that there is a construct called select uniques. And how to use select uniques? I'll show you a quick example is that in select uniques, this is the normal query by primary key. But now going forward, you can start having these customized query root fields. And in this case, the unique identifier is using these two fields in the database. So glad to tell you that this issue is now closed and let us know how you are using it in production right now. And real quickly, the next one also, with our aim to provide clarity and self-documentation for the GraphQL schema. This is an RFC we are working on. We'll share the links with you over chat and over email. Let us know what you think. But basically with this, you'll be able to provide custom description to different type and fields in the metadata so that your GraphQL API will represent these custom description. And something, for example, is that an object type, you'll be able to describe about that object type to your API consumer. One example which shows this very clearly is something like this here, where you are able to provide what does this author many type mean, and then what are the different query root fields about. So metadata description on different types and fields coming soon. Let us know what you think about this. And willing to provide more updates in the next Backlog Bash.
All right, folks, let's close things out here with a couple of our typical updates. We want to remind you that we have Discord office hours every Tuesday at 10 a.m. Pacific. You can access our Discord server by hitting the link in this presentation, which will be shared out with everybody. And then you can also find that information on our website. You can jump into this call for, just talking about what's coming through for DDN. If you want to ask questions, you want to talk with some of us, we're there. We'd love to have conversations with you and just find out what you're building with Hasura, or do our best to answer any questions that you may have. I did allude earlier to saying that there are some new resources available. We have 2 new Learn courses, one for how to model supergraphs. So this is taking the concepts that we're trying to double down on in V3. We have assets available for you to make it really easy, so you can spin up a Docker Compose that has a series of different relational databases, and then you can create a supergraph from that in that course. And then finally, we've turned our NDC Learn repo, which is a series of videos from some of the engineers that worked on the actual NDC spec for how to build a connector using the TypeScript SDK. So you'll go through and build one for local file storage there. So those are 2 resources we're checking out to see all the new things that are coming through in V3. As always, we're excited to get your feedback, and we'll take it anywhere you want to give it to us, including the docs feedback component if you do have feedback about individual pages of documentation. This has been a great start to 2024. We hope it has been for you, and we will see you in the next community call in February. See you, folks.